Good morning, everyone. Yes, my name is Bronwen. I wear a lot of hats, like a lot of you might. I'm a daughter, a sister, I'm a business owner, I am an employee, but deep down at heart, I am a developer, and I have been a developer for longer than I haven't been. So what that really means is, one, that I'm old, and two, that I've seen lots and lots of stuff over the years. I also love digging through lots of people's data. Over the years, I navigate through the businesses and find a spreadsheet here and find a little database there, and it's always really, really interesting. So a lot of this is from the perspective of me being a developer. Many of you may not be developers. Sometimes these people that come might be, I don't know who's a data professional versus a developer versus a BA versus a report developer. But the other way to think about this is how to go back to your teams and talk to them and talk to the developers about these different types of architectures. So these days, it's almost an indisputable fact that data has a lot of value, even to the point that a lot of people will start to put that on their balance sheet now. But what does that actually mean? What are the key things that drive value of data? Because just having it doesn't mean it's worth anything. So here are the few ones that I think are the top three. The ability to make good decisions informed by data. What does that mean? Well, it's been interesting being in Sydney and talking to people. I was asking the other day, what's the best way to get back to the airport? Who here would have said, catch the train? Yeah. How many would have told me to jump in an Uber? One? Yeah. That's your decision right at the moment. That's your opinion of what I should do. What if I told you that I'm a terrible overpacker and I have 3 giant suitcases? How many people would now tell me to get on the train? Yeah, a lot less, yeah. What if I'm awesome and I only have carry-on, but I brought 3 of my friends, we're all on the same flight? Train? Couple? Uber? 50-50? And then what if, like last time I was in Sydney, the rain was terrible and all the signals are out and it's going to take, I'm not quite sure if I can get to the airport at the moment with all the flooding. What would we do then? Would I catch the train? The Uber? Because everyone else is going to get an Uber. What other options could I possibly have? Helicopter. Hey, that's a really inventive one. Because you didn't know my budget, right? I'm super rich. I can get on that helipad and just helicopter to the airport. Sorry, what was that one? That's right, give up entirely and just stay in Sydney for the night. And this is why making decisions based on data that is accurate can be very, very important. So that's principle 1. The speed of the insights to get the decisions faster. It's all well and good to have this data, but if you have it too late, it's no good to you. So if you're trading stock and you have this awesome process, you get all the data, but it's a week old, how useful is that to you if you're buying at the high and selling at the low? It's really important to think about what speed you need each piece of data and how useful it will be at that time. One of the most important ones to me is being able to be confident that the insights are accurate and you can trust it. So what's worse to me than having no data sometimes is having data that you're not sure is right. Who's got a garage door with a little button pressy thing, yeah? And you press it and it doesn't go, and you press it again, and you press it again, and you're driving off, it's is the garage door gonna close? If I haven't got this right, then some dude's gonna come in and get into my house and take all my cool toys and tools while I'm out. If your data isn't accurate and people can't trust it, they're not gonna use it. If you don't have a way to indicate to people the accuracy and your confidence in that data and how old it is, people won't use it, and then the value is degraded. I think this is one of the most overlooked ones sometimes. A lot of us will set up these amazing data platforms where we'll have accurate data, it'll be speedy, it's like we've done all the right things, but then we lock it down and we make the process for people being able to access the data really, really hard, or they can't find it. Who has to fill out lots of like SARF forms and access forms to get access to anything at work? Oh, wow. Different crowd. Okay, cool. You guys are set then. A lot of my clients and a lot of people I work with, like, they have a lot of trouble getting access to these things, which makes, again, the data completely useless. So you guys are sorted. All good. So now we've looked at what the value drivers for the data are, let's look at the principles when we're thinking about different architectures and the ways to use the data. So data by itself doesn't create the value. You've got to be able to turn the data into actionable insights that empowers the people to make decisions. That's the thing that creates the actual value. For me, when I'm looking at whether or not I should re-architect a platform, or even code as well, but data as well, for me, I look at the return on investment. And unless you have a different type of reason, I generally don't even look at it unless I can see a 10 times return, either through increasing the revenue or reduced expenditure. Now, my exceptions to that are generally things where, like, something's going to go out of support, there's a massive security issue, and then your return on investment might be a different type of measurement. So for instance, if you're looking at doing, let's say you're looking at doing green computing, and you're looking at it as a principle of, like, I want to make the world better in the long term, the ROI is a little bit different. So you might do something that costs more, but the payoff isn't directly on your bottom line. Those are sorts of the exceptions. But generally, like, if you're not going to get a lot of benefit about the re-architecture, use it and use it and use it until it's no longer suitable for you. So to summarize those to you, we need data, we need insights for the data, and we need action. So you need someone to be able to do something with it, but you need it to be done by the right people at speed. Because if someone isn't doing anything with it in a timely manner, again, the data is invaluable. So now we get to the more, maybe the more boring part for some people. So the landscape overview, so the different types of parts that make up these architectures. So for the architectures, what I'm going to go through today are some of the key players. So the first one is database. Then we're going to look at data warehouse. Then we're going to look at data lake, and then lakehouse. They're sort of the key architectures. In amongst that, there's a bunch of things that I call the ecosystems. So they're present in all of them, and they play different roles. So we have things like data factories to get the data in, streaming hubs to stream data around. The extra one that I will add into the data architectures is the data meshes. At the moment, I still feel like that's an ecosystem, but I think people are trending that way, so we will talk about that one last. Your virtualization, federation, very important is your data governance, especially as you go through these bigger architectures. And of course, the hot topic of the last year has been things like AI copilots. So they're the ecosystems. So we won't delve into those very deeply. So we can't talk about the value of data and data architectures and what's good and what's not without having more data. So for each of them, what we're going to do is look at some of the metrics that I use to determine where things fit. And I'll go through each of these quickly. So given them a nice little icon, and when I show you the next lot of slides, I'll give them a scale of 1 to 10. 1 being bad, 10 being good. And it will may get confusing as I go through, so I'll touch on each one. So speed. This is how fast you can get the data from the source system to the people that need to do it. How fast it is to do this dev, get the integration in. Complexity. How complex the architecture and the environment, how many bits and pieces are there to it? Skills. What sort of people how niche are their skills that do you need to be able to do these things? Cost. How much money is it going to cost you to run, maintain, keep the people, all those sorts of things. Scalability. How quickly can you scale it up once you get more and more and more data? Latency. So this is the one that can be a bit confusing. Usually you want low latency, but I'm going to say if it's a low latency, it's a 10, so that we keep it 1 to 10 rather than flipping it backwards. So if you're nice and quick, if the latency to get the data there is low, I'll give that a 10, as opposed to being slow latency. And then the last one, AI integration. So for this one, I'm talking more of the AI integration where you need someone with AI skills as opposed to some of like the plug-and-play co-pilots and stuff like that that are available today, where you need a dedicated sort of AI type team. All good with that? So let's have a look at each architecture. So the first one is the database. So has everyone used the database? Yeah, cool, right. Awesome. Database is where most of us start. How many people have used a database that's 5 years old? Keep your hand up. 10, 15, 20 years old, 25. What's your number? What's your oldest database? How old's the database?
No, never mind.
Yeah? A lot of these databases live a long time. For the people that had something that was over 10 years old, how many of you had it been through multiple different UI versions? No one? Yeah, a couple? Yeah, so a lot of time you'll flip through, you'll do a UI refresh, but the database will live on. A lot of these databases, when they first were developed, someone did a really, really good job at making sure the indexes were tuned for the thing at the time, and the data drifts over time. You add a column here, you add a thing there. The world moves on. I've worked on a few. Who's old enough to remember before GST? Before GST, yep, cool. Everyone used to have an Australian company number, and now, and then back then, a lot of people didn't have an ABN because a lot of people weren't registered for GST. So a lot of those databases would have had indexes on ACN. Now, if they haven't maintained them, they're trying to do searches for ABN, and they're finding their databases are slow. So people try to move off the database too quickly, generally, I find, to a warehouse rather than solving the problems with the technology that they have. Fixing the data, making sure your data quality is right. When you have that here, it makes everything really, really a lot easier later down the track. The example I've given you here, it's a little bit more than the most basic. So the most basic would be a web app or some sort of UI that talks to your business logic and database. I've added here as you have some sort of ingestion. You're getting data from somewhere else as well. That's database. So this is my base level. So this is my numbers. In your situation, your numbers might be slightly different, and each application is going to be slightly different. So these are my baselines. And when we compare, we'll be comparing to a database. I think the ones to point out for this one is, at this point, your costs and your skills are probably the lowest they're going to ever be, because it's one of the simplest architectures you can have. What we tend to move on to next is a data warehouse. So you started integrating a lot of data, you've pulled things from other places, different parts of the business want to talk and share data, and this is when you've moved off to a data warehouse. A lot of us will start by adding that to our database, but when I'm talking data warehouse, usually it's when you want to do a lot of reporting. You want to do historization, so you want to take possibly like daily snapshots so you can run comparisons day to day. And for me, the big distinction is usually when people stop writing their create, read, update, deletes on that particular database, because generally a warehouse is a big database. This pattern's been around for a really long time. It serves lots and lots of purposes and works really well. So the thing that you get here with once you move up to a data warehouse is you have a slight incremental skill uptick because you need to understand it in a different way. You need to be able to export the data out in a way that's more relevant to a report. So we might have done third normal form in our database, but when we want to do a report, we want to flatten that out. Things start to get a little bit more costly because you've got a bigger database, more storage, and it's a little bit, the scalability increases. You're adding your scale. But your latency decreases because you've got that little extra hop to go from your database to your warehouse. Next, a lot of us would have moved possibly to a data lake. So the key difference with this guy, in addition, sorry, I'll go back one for you. So here, with your data warehouse, you're generally grabbing a bunch of different databases and some structure and ETLing that into your warehouse, and then your application can sit on your reporting. Once we move up to our data lake, this is when people start to integrate things that aren't necessarily relational data. And you ended up with your data lake. Now, here is where we start adding a bunch generally, tend to start adding a bunch of that sort of machine learning and data science. And if they move it into the data lake, this is where the first thing a lot of people find is they still need their warehouse type pattern because we need to do reporting on it. Yep. ETL? Sorry, my bad. ETL is extract, transform, and load. Or some people will go the other way and do ELT, extract, load, and transform, depending on the pattern that you want to use. Yep, thank you. So here, what typically happens is you sort of end up in a bit of the worst of both worlds because you end up with two systems running to be able to do your reporting. Because generally, you can't run what your favorite reporting package is to sit over the top of the data lake. You usually then will have to ETL that out into another database so that you can get to it easily. And then, because these numbers are a little bit clearer for you, yeah. So at this point, it's got a lot more complex because we've introduced not only a warehouse, but also a data lake. And the other one is we end up with a lot more components because now we've got lots of things running. Our costs at this point is also getting quite additional. And it tends to be one of the worst performing patterns because we're making changes to multiple places in one spot. At this point, things like your data governance need to be really on top of things. So a lot of the time, you need to know who owns the data, and you want to really push that back on as far back down the chain you can. So a lot of the time, you'll see a lot of problems with someone will write a report or they'll do some new machine learning thing and find a problem in the data, and they're trying to fix it as part of their process. A typical thing will be like, there's some data missing, and so they'll make a query that fixes that for the report. The biggest problem with that is it doesn't show up on the report, so then you don't know it's wrong. What you want them to do is to be able to tell you so that you can go back to your database and do a data fix or make a change so that it's easier for them. Having that ownership, being able to track how old it is, the last time it's updated, the quality of the data, the lineage, all that stuff becomes more and more important as we start to scale. Because we want to be able to trust the data, but we also don't want to have to query it in 3 different places and get 3 different answers. Because if you ask what is, like, how old a part for something is, and you get 3 different dates, you don't know which one is correct. And then you start to, again, distrust the data. So if I was starting today, I would tend to skip over this one now because the newer pattern fixes a lot of the duplication problems. So the lake house pattern, again, here you start to add a lot more software to help you with these processes. This one means that you can simplify again, and then we're back to one big lake house, and you can drop your data warehouse off. So this one here, similar to the one before, but it is actually less components. It's a simpler architecture. So this one, because we've done that, we've reduced, the biggest one you'll see here is that we've reduced some of our complexity. At the moment, I think it still needs extra skills because a lot of these are, custom products. Not everyone knows how to use them. A lot of people know how to use a database and write a SQL query or a NoSQL query, but it's just a little uptick in skill. But I think a lot of these products are starting to make it simpler for us. I think that skill difference will start to come down. And now that you've got a lot of this streaming support, so you can get lots of files, your IoT data, you can do a lot more interesting things with the machine learning. So your ability to do a lot of the more interesting AI things across your data increases with these really bigger architectures. And so this is where the architecture kind of starts to meet that ecosystem concept. So once you have one, you can have multiple. So this is where a mesh concept comes into play. So didn't have a lot of room on the diagram, so I'm trying to indicate a few things here. So you could have lots of little apps here. They talk to different lake houses. And each of those lake houses could have, or you might have one, it's up to you, different reporting, data science and machine learning, and then those lake houses could talk to each other. Why would you do that? You might have teams, domains within your business, types of data that are on different timescales. So you may have teams and data that it's really easy to get it out and change it fast, and you have others that move more slowly, or it might have different privacy. So it allows you to work at different speeds, or you end up back at a giant monolith, which can be really, really hard at a scale like this. Like this is when you have lots and lots of data, generally. So once we get to this point, our data sharing actually increases because we have a little bit more flexibility. But yeah, at this point, your cost is pretty much right up there. It's not going to get much more expensive because you can, at this scale, you've got lots and lots of, usually, compute cost. So to summarize all that, I'm going to go through just a little example, fake example, just to summarize how that journey can tend to take. A lot of people can come at it different ways, but here is one example. So this is Jenny. Jenny is a developer. She works at a rental car company on their application. The rental car company, they've been around a long time. It's an old database. She's been doing her best. She's been upgrading it to the latest, front-end UI. She's got the database running really, really well. So she started at the absolute most basic app. She's got a little web app talking to the database. It works great for the rental car company. Over the years, they've started to grow. And she was at the water cooler the other day talking to Toby. Toby works in maintenance. He has a lot of really interesting data about the maintenance schedules for the cars. Now, they're trying to optimize, when you're a rental company, you don't want to have your cars out of action, you don't want to oversell them. It's like, it'd be really good, you could use some of our data. So she decides to start doing her own ingestion based on his data. And what does Toby have access to? What is the hammer that everyone has in their toolbox? He has the ability to get it out as an Excel file. As much as I'd love to kill Excel, it is a format that is really generally easy for everyone to get out of their system. So she starts importing it, works the first time, works the second time, third time breaks. Goes back, he talks to his guy, and they work out that he ticked some different options in the tick box, and the report's different now. So they standardize that. They get it going. They're happy. That's going along now well. They're really happy. It's improved their ability to have the best uptime on their cars. They start to integrate a few more things, and then they come across Debbie, and Debbie's like, hey, this is really awesome. You have all this data. The management are really interested in this, and we need some reports. But we don't want to hit your production database, and it's a lot of data, and we're starting to integrate with lots of people now. And we don't need real-time data, so it's okay that it's a day old. So they work together as a team, and they come up now with this data warehouse type pattern. So there's a bunch of data coming from different places around the business. We've now got our data warehouse. which instead of getting it from Toby, now we're getting it from our warehouse to pull into our application to show for stuff that we need. And then we're able to put a reporting layer on that as well to share for other parts of the businesses so that the management can see that, our car utilization has been improved. Next, we come across, they started to employ a few data scientists because we've seen some improvements here, like integrating this data, but what could we do if we could predict things? If we looked at things like weather, if we sucked in all the holidays and stuff like that, events around the country, what could we work out in terms of car utilization so that we have the optimal number of cars available for people so that they are always utilized and we're never giving people more expensive cars than they've actually rented out. So we've introduced the machine learning into this. So we need to go a little bit further than the warehouse. So at this point, we move up to our lakehouse. So again, we've got our ETL and storage. We've got a bunch of live telemetry. We know where the cars are. We're getting live feeds. We know every bump they've been over, and we're doing predictive maintenance. So we don't just wait for the 10,000 Ks. We know that it was a bit rough. We're gonna be a bit smarter. So now we've moved to this pattern. This is great. We're killing it with this application. We've seen the car utilization go up. The management's super happy. Then what happens? The other team, they're like, those guys are doing it. We can do this too. But their data is more secure. They've got a bunch of finance and HR data. The legal people are a bit, not sure about this. So they're on a different time frame, and we don't want to slow down. We don't want to make a giant monolith. We want to keep improving. So we work with the other team, and we decide that it's definitely worth it for the return on investment for the whole entire company, because we're a massive rental car company now. We are like Hertz. So now we move to that concept of a data mesh. So the other team, we can mix it up by domains. Each one can have their own set of data, and we can share what we need, and they can work on different timescales to us. And that is my summary of how it may evolve for you. Cool. So when doing this, there's a bunch of key factors that we need to consider. Start simple. So don't be afraid of starting with a database and having a bit of a monolith, because things change quickly. So start simple. A lot of people go, I call it resume-driven development. A lot of us will see the shiny new thing and want to go straight to that, but sometimes it's really good to start simple. Cloud can be cost-effective, but start by getting access to your data. Who has access to their production cloud data costs? Quite a few, cool. Yeah, a lot of places I work, devs can't see it. So it's really hard when you're implementing this stuff to know how much it's costing. And having alerts, because it's really easy to start doing a new integration and make a little error and not realize it in the scheme of the rolled up cloud cost. So definitely set that up from day zero and have really, really good alerts, and that can keep the costs effective. Latency is definitely a killer. So you'll find once you have it, people love the data in one place, but not if it's out of date. My biggest analogy for that is if you read the trashy tabloids, the front cover photo is always this horrible photo of whatever celebrity in their pajamas, and it's horrible and out of focus. That's because they get paid to be the first. Doesn't have to be a great quality photo, but it has to be right. And then the guy that takes longer and sits there and gets an in focus, beautiful makeup, right angle, beautiful sunlight, he doesn't get paid because it took him an hour. Think about latency, because it can kill. And then aim to deliver in months. A lot of these patterns, you're gonna migrate. You're not gonna go from a database to a lakehouse mesh overnight. But aim to deliver something and get the pattern working within months, because technology changes, AI is coming, and you need to prepare for the challenge. So just to summarize, your ability to deliver quickly for the business will provide return on investment. Don't take 3 years to develop a complex data platform before you deliver anything, or it'll be outdated by the time you're finished and you have to start again. It's okay to start with a simple database. You don't need to aim for the most complex. It's okay to do things like copy data. I have no problems with people making copies a couple of times, especially if it's the first one or two. By the time you're doing 10, that's when you need to centralize. Low latency is definitely the key for your data platforms. The quicker you can get your data in an accurate form there, the better your platform is going to be. Cloud enables your low costs at scale, and it allows your scalability, but make sure you dedicate effort to monitoring the costs and the effort and what's going on and tune that. And then I think AI is going to revolutionize, and we've already started that change to see how we access and manage and make decisions based on data. And it should be the catalyst to invest in getting your data right. So thank you very much. Been great being at RubyConf. This is my first time, so thank you all for coming.